Welcome. In this video, we are going to study the calculation of R and C series circuit. Here one circuit is drawn. It consists a resistance of 50 ohm and a capacitor of capacitance 100 microfarad capacitor. Both are in series. The series combination connected across a 230 volt 50 hertz supply. So now the given data, the voltage is given 230 volt and the frequency given 50 hertz and the resistance is given 50 ohm and the capacitor is given 100 microfarad. Here micro is come, so we have to convert it to micro into it's 10 to the power minus 6. So we know that milli is represented at 10 to the minus 3 and micro. So micro symbol, micro is 10 to the power minus 6 and nano is 10 to the power minus 9 and pico is 10 to the power, it's represent 10 to the power minus 12 like this. Clear? So just remember the points. Clear? So in this problem we have to calculate the total opposition offered to the flow of current. Next we have to find the total current, how much current is flowing here. So first to find the total opposition offered to the flow of current, that is Z. To find the Z, we have to calculate Xc, capacitive reactance value we have to find. Next we can calculate the total impedance Z value. Once know the Z value, we can calculate the total current, and if we know the current, next we can calculate the power factor and the apparent power, active power and reactive power. All the calculations we can do based on these values. Clear? So we are going on Xc, that is capacitive reactance. The equation is 1 by 2 pi Fc. Clear? 1 by 2 pi Fc. Here 1 by 2 into pi into F is 50 hertz. So frequency 50 into C, capacitor value is 100 micro. So micro here converted 10 to the power minus 6. So don't forget the 10 to the power minus 6. This is a micro conversion. 100 into 10 to the power minus 6. So while doing this calculation, we will get the 31.83 ohm Xc value. The capacitive reactance is 31.83 ohms. Now both are in same unit, ohms and ohms. Clear? We calculated its capacitive reactance Xc, that is 31.83 ohm. So both are in ohms. So next we can calculate the total opposition offered to the current, that is impedance. Impedance Z equal to root of R square plus Xc square, that is root of R is given, R is 50 ohm, so 50 square plus Z X is calculated 31.83 square, so we will get 59.27 ohms. This much impedance Z equal to 59.27 ohms. So now we can calculate the first one, the total current I equal to voltage by total opposition, V by Z. So V is 230 volt divided by Z is 59.27. So 230 divided by 59.27 we will get 3.88 ampere. So total current is 3.88 ampere we get. Next is power factor. So we know the equations. Power factor equal to cos phi, that is equal to R by Z. R is the resistance value, Z is the impedance value. So that is equal to 50 by 59.27, that is equal to 0.843. That is leading condition. Why leading means it's a RC conditions. So capacitance circuit. Clear? So capacitor circuit has a leading behavior. So leading. Next is apparent power. So apparent power equal to voltage into current. So voltage is 230 and current is total current is 3.88. So 230 into 3.88 is equal to 892.4 volt ampere. This much apparent power we get. Next is active power. So we know the equation, active power equal to VI cos phi. So V is 230 and I is total current is 3.88 into cos phi. Cos phi value, power factor cos phi equal to 0.843. So 0.483. So multiplying this value 230 into 3.88 into 0.843 we will get 752.83 watts. This much active power dissipates in the circuit. Next is reactive power. To find the reactive power, we should know the sin phi value. Here active power cos phi, here sin phi for reactive power. So we know the cos phi equal to this much value, 0.843. So phi equal to cos inverse 0.843. So while doing the cos inverse, we will get phi equal to 32.54 degree, this much degree. So applying here sin phi, sin 32.54 equal to 0.5379. So we can substitute this value here in the reactive power. So 230 voltage and current is 3.88 into sin phi, that is 0.5379. So while multiplying, we will get 480.03. So 480 volt ampere reactive. Here R is stands for reactive, volt ampere reactive. So it's one sample calculation for RC circuit. Based on the given data, we started the calculations.